Good morning, children. Welcome back to Ican Physics. Now, in this class, we are going to solve 2021 55 bar 4 bar 1. Question number 32. Let's enrich your knowledge. Question number 32. A. Question number 1. Draw a ray diagram to show how the final image is formed at infinity in an astronomical refracting telescope. Obtain an expression for its magnifying power. Now, question number 32, A1, astronomical telescope. Okay, so what is telescope? So, seeing at a distance. What is astronomical telescope? The telescope which is used to see the astronomical objects like stars, planet, asteroids, like that. Okay. So the astronomical telescope consists of two convex lenses. One is objective lens and another one is eye lens. So the objective lens of long focal length. And just to compare the lenses, then it has a larger aperture. Okay. Now, both are placed coaxially on the same axis inside the tube. Okay. Now, the light from the distant object, say it may be a star, or it may be a planet, or it may be any celestial object. So, the ray one which is passing through the pole is undeviated. Okay. And the next one, the ray which is parallel to the principal axis, which passes through the focus and meet the ray. At that point, we can get the real image. Okay. Here we have to give importance to the arrow head. Okay. So, A dash, B dash is formed at a second focal point. Okay. Now, the distance from the objective lens to the image formed is F naught. That is focal length of objective lens. Now, this real image acting as object for the second eyepiece. Okay. Now, from that, we can get the deviated ray and it will be refracted and we can get the highly enlarged, inverted final image on the same side. Okay. Now it forms two angles. One is alpha and another one is beta. So now I am going to calculate alpha and beta. Okay. So for alpha, so I want to cut the triangle like this. Okay. Okay. So it will be H. Then it will be F naught. Here it makes an angle alpha. Okay. Here you can cut the triangle. Okay. This beta is H. F E. Okay. Now it's alpha. We know the opposite side and also the adjacent side. So opposite side, adjacent side. So that I want to take the tan component. So what is tan? Theta, opposite side by adjacent side. So for instead of theta, I can write alpha equal to. So which is the opposite side? H. Which is the adjacent side? F naught. So being small angle, we can neglect the word turn. Then alpha equal to H by F naught. Okay. So like that we can go for tan beta. Okay. So which is the opposite side? H. Okay. So which is the adjacent side? F E. Being small angle, we can neglect the word turn. So beta equal to H by F E. Okay. So from that what we can calculate? We can calculate the magnification. Okay. So what is the formula to calculate the magnification? That is beta by alpha. Okay. So now what is the value of beta? H by Fe. Okay. H by Fe. Divided by alpha, h by f naught. So h by f naught. Now reciprocal the value. So when you reciprocal the value, h by f e into, when it becomes reciprocal, f naught by h. So h getting cancelled. So finally we can get the magnification. So in the numerator we are having f naught. In the denominator we are having fe. So thus we can calculate the magnification. Okay. So how I can calculate the length of the telescope? So the length of the telescope is f naught plus fe. Okay. Do you get it now? Do you have any doubts? No doubt. So hope that you know our Ican Physics Academy. Our Ican Physics Academy gives the baseline for CBSE Physics and State Board Physics. Okay. In that, what we are doing? So we are simplifying the concepts and gives enormous reels based on your +2 physics. So subscribe our channel, follow our channel and share our channel. Okay. Question number 32. Two thin lenses L1 and L2. L1 being a convex lens of a focal length 24 centimeter and L2 a concave lens of a focal length 18 centimeter are placed coaxially at a separation of 45 centimeter. A 1 centimeter tall object is placed in front of the lens L1 at a distance of 36 centimeter. Find the location and height of the image formed by the combination. Right. So from the question, we can come to know that two lenses, one is convex, another one is concave. They are placed at a distance of 45 centimeter. Okay. Now, it's a convex lens. It's taken as L1. The object is placed at a distance of 36 centimeter and the object of height 1 centimeter. Okay. So from that, what we are going to calculate? For lens 1. For lens 1. So what is the lens formula? 1 by f equal to 1 by v minus 1 by u. Okay. Here, the focal length of 24 centimeter. Here it is taken as positive. Why it is taken as positive? Okay. Now, the incident ray which comes and forms the image, so that this image is right side of the pole of the convex lens, so that f is taken as positive. So f value is 24. Okay. So 1 by 24 equal to 1 by v. So that only we are going to calculate. Now the object distance u. Here the u is taken as minus 36. So why it is taken as minus 36? Because this is the pole. So from the pole we are measuring the object distance which lies on the left side. So that we take into account of minus. So minus 36. Now minus becomes plus. So 1 by 24 equal to 1 by v plus 1 by 36. The plus 36 comes to this as minus 36. So 1 by 24 minus 1 by 36 equal to 1 by v. Okay. So now we can go for LCM. So denominator into denominator. So 24 into 36. Now cross multiply. 1 into 36, 36. 1 into 24, 24. Equal to 1 by v. So 6 minus 4, 2. 3 minus 2, 1. Divided by 24 into 36 equal to 1 by v. So 1 12 is 12. 2 12s are 24. Okay. So now we are getting 36 into 2. So 72. So 1 by 72 equal to v. Now reciprocal the value. So v equal to 72 centimeter. So the image for the convex lens is obtained on the right side, so that we can obtain the positive value, then we can say our answer is a correct one. Okay, do you get it now? Do you have any doubts? No doubts. Now we can go for concave lens. So for concave lens, we know only f dash. Okay, so for a lens 2, for lens 2, so it's taken as L2. Okay, so that we also taken L2. Okay, so 1 by f dash equal to 1 by v dash minus 1 by u dash. So this is the formula. So the same formula is modified. Here 1 by f equal to 1 by v minus 1 by u. Here 1 by f dash equal to 1 by v dash minus 1 by u dash. Now we are going to calculate the value of u dash. So how we can calculate the value of u dash? So the image is formed between the two. Okay, so 72 is v. But what about the distance between the two lenses is 45. So distance between the two lenses is 45. So when we are subtracting the value, then we can get the value of object distance for the second one. So object distance u dash equal to 72 minus 45. So 12 minus 5, 7. So 6. 6 minus 4, 2. So u dash is 27 centimeter. Now we can substitute the value. Okay, so 1 by f dash. So what is the value of f dash? Minus 18 equal to 1 by v dash minus 1 by u dash. So 1 by 27. So the minus 1 by 27 comes to this as plus. So 1 by 27 minus 1 by 18 equal to 1 by v dash. So now we can go for LCM. Okay, so 27 into 18. Now 18 minus 1 into 27, 27 equal to 1 by v dash. Okay, so 279. So minus 9 by 27 into 18 equal to 1 by v dash. So 1 9 is 9. 2 9s are 18. So 2 into 10. So 1 by. So reciprocal the value. So v dash equal to minus 54 centimeter. So the final image is obtained at a distance of 54 centimeter. So what is our question? What is the final image? Okay. So final image distance. Final image. So what about the final image position? That is 54 minus the distance between the two lenses is 45. So 54 minus 45. Then we can get the final image at a distance of 9 centimeter. Okay. Do you get it now? Do you have any doubts? No doubts. Okay. So what is the question? What is the final image distance? Okay. So the final image distance, it can be taken as V1. That is equal to V dash minus distance between the two lenses. That can be taken as D. Okay. So what is V dash? V dash is minus 54. This is the symbol minus. The distance is 45. Okay. So from the concave, it is the distance of 45 in the left side. So for concave, the distance is taken as minus 45. So minus 45. So minus 45 plus, so minus 54 plus 45. Then we can get minus 9 is the final image distance. That is minus 9 centimeter. So from that what we can say? So from 9 centimeter of the convex lens to the left, the final image is obtained. Okay. So final image V1 is obtained here. Okay. So what about the next one? What is the magnification? Okay. So for magnification, I want to take this point. Okay. So magnification equal to h dash by h equal to v1 by u. H dash, that only I am going to calculate. H is taken as 1. Okay. V1 is minus 9. Minus 9 divided by u. So u is the distance of convex lens of minus 36. So minus minus getting cancelled. 1 9 is 9. 4 9s are 36. So h equal to 1 by 4. 1 by 4 centimeter. So the object height is 1 centimeter. Now we are having 1/4 is the final image of h dash. Okay. So we can get the minimized image. Okay. Do you get it now? Any doubts? No doubt. Okay. So for our CBSE system of education, we have solved the exercise problems from the volume 1 for 8 lessons. Okay. Then we are solving the previous year questions. So already we have solved 2020. Now we are solving 2021. Okay. So these are all long videos. Okay. So to learn a simple concept in a single minute or within a reel. So we have produced more than 100 reels for +2 physics. So to see that, to enrich your knowledge, so subscribe our Ican Physics Academy channel and follow it and share it. Okay. The next question is 32B, question number 1. Explain the principle of an optical fiber with the help of a diagram. Mention one use of a light pipe. Optical fiber is based on the phenomena of total internal reflection. Okay. The optical fiber consists of 2 cores. Okay. So the inner one is called a core and the outer one is called a cladding. Okay. The refractive index of core is greater than the refractive index of the cladding, so that the total internal reflection takes place. The light which falls on the core, it must have some acceptance angle. Okay. So incident acceptance angle IA equal to sine inverse of square root of n1 squared minus n2 squared by n3 squared. Here, what is n3? So n3 is the refractive index of the air. So the refractive index of the air must be 1. So that the final answer IA equal to sine inverse of square root of n1 squared minus n2 squared. By using that, we can calculate the acceptance angle. At that angle, total internal reflection takes place. Okay. So what is the use of the optical fiber? The optical fiber is used to transmit the audio signals, video signals, and also it is used in the endoscopy. So we know that the endoscopy is used to see the internal organs. Okay. Question number 32 or question 2. A ray of light is incident at an angle of 60 degree in one face of a prism with the prism angle A equal to 60 degree. The ray passes symmetrically through the prism. Find the angle of minimum deviation, del m, and the refractive index of the material of the prism. If the prism is immersed in water, how will del m be affected? Justify your answer. Okay. Now, we have to calculate the del m. Okay. So, what is the formula for del m? That is incident angle plus angle of emergence minus A. Okay. So, I and E are equal. equal. So I plus I, it becomes 2I. So 2I minus A. Okay. So del M equal to 2I minus A. So what is the angle of incidence? 60 degree. Okay. Minus what is the angle of the prism? 60 degree. So 2 into 60, 120 minus 60. So 60 degree is our answer. Refractive index equal to sine A plus del M divided by 2 divided by sine A by 2. Okay. So sine A, angle of the prism, is 60 plus del M is 60 divided by 2 divided by sine 60 by 2. Okay, so 60 plus 60, 120. So sine 120 by 2 divided by sine 60 by 2. So it becomes 30. So 1, 2 is 2. 62 is 120. So finally we can get sine 60 by sine 30. Okay. So what is the value of sine 60? Okay. So theta 0, 30, 45, 60, 90 for sine. So sine 0, 0. Sine 30, 1 by 2. 1 by root 2. Root 3 by 2. 1. Okay. So sine 60. So what is the value of sine 60? It is root 3 by 2. Okay. So mu equal to root 3 by 2 divided by sine 30. So what is the value of sine 30? 1 by 2. 1 by 2. Now it becomes a reciprocal. So when it becomes reciprocal, root 3 by 2 into 2 by 1. So 2 getting cancelled. Then the refractive index is root 3. Okay. Which has no unit. Okay. So when it is immersed inside the liquid or water, what happens? The refractive index decreases. Refractive index decreases. So that the angle of minimum deviation is also decreases. Okay. Do you get it now? Do you need doubts? No doubts.